You know, every car has its own personality. And whether we even realize it, we're all fluent in its secret language, the language of sounds and feelings. Today, we're going to decode that language. We're diving into the hidden science of how engineers actually design the soul of your car.
I mean, really think about it. It's that super satisfying thud you hear when you shut the door. It's the hum of the engine, the feeling in the steering wheel. None of that is an accident. Oh no. Every single one of those sensations is a carefully crafted signature.
So in the auto industry, they have this technical term for all this stuff, NVH. It stands for noise, vibration, and harshness. And it basically covers everything you can possibly hear or feel in a car. But, you know, NVH is kind of clinical, right? Let's just call it what it really is, a car's acoustic signature. Sounds way cooler.
So why do car makers spend so much time and money obsessing over this hidden language? Well, it goes way, way beyond just trying to make a car quiet. It's about crafting the entire experience that defines a brand.
Okay, let's break it down. First off, this signature is basically the brand's DNA, but you can hear it and feel it. It's what makes a rugged truck feel different from a smooth luxury sedan. It also totally shapes how you perceive quality, that solid, safe feeling that tells you this is a well-built machine. And of course, that influences whether you buy the car and if you'll stick with that brand later. And get this, it even affects warranty costs. Because one of the top reasons people take their cars back to the dealer is some new, weird rattle or buzz they've never heard before.
Now, you'd probably think that with all our modern tech, getting this stuff right would be easier than ever. But here's the big twist. The very things that are making cars better, more efficient, more electric, are actually creating a massive, brand new challenge for the engineers.
Okay, so here's the heart of the problem. A good old-fashioned gas engine creates this constant, low-rumble background noise. It's kind of like the background music in a busy restaurant. It masks all the other little distracting sounds. But in an electric vehicle, that engine is gone. The background music has been switched off. And suddenly you hear everything. Every little high-pitched whine from the electronics, the wind noise, the sound of the tires on the pavement.
And the plot thickens, because this challenge doesn't stop with EVs. Nope. Other modern design choices are just making the problem even trickier.
It's this crazy domino effect. So we all want better efficiency, right? That means cars are built with lighter materials. But lighter materials transmit more vibration. At the very same time, we, the customers, expect the inside of the car to be quieter than ever. So you've got this perfect storm where the old background noise is gone, the car is vibrating more, and now you notice all these tiny, annoying, high-pitched sounds that were completely hidden before.
And this really gets to the core issue with the old way of designing a car's feel. Engineers used to just stare at charts, graphs, and spreadsheets full of numbers. But that data is totally abstract. It doesn't tell you a single thing about what a car actually feels or sounds like to a real person.
To solve this, the whole industry needed a major breakthrough. They had to find a way to bridge the gap between all that cold, hard data and the very real, very human experience of driving. They literally needed to find a way to turn data back into feeling.
And you can really see the huge shift that had to happen right here. The old way was just stacks of data, a whole lot of educated guesswork, and then building these incredibly expensive physical prototypes, only to find problems really late in the game. The new way had to be completely different. It had to be about creating an immersive, interactive experience, something that let engineers make smart, confident decisions digitally, long before anyone even thought about building something real.
The solution that popped up is, well, it's just as elegant as it is powerful. It's a system that works exactly like a flight simulator. But instead of training pilots, it lets engineers truly experience the sound and the feel of a car.
And this is where this amazing concept called a digital twin comes into play. This technology lets engineers build a completely virtual, totally drivable version of a car using nothing but simulation data. So, what does that mean? It means they can literally get in and drive a car that hasn't even been built yet. How cool is that?
And it's not some one-size-fits-all thing either. It's like a whole toolkit. For a quick A versus B sound test, an engineer can just use a desktop simulator right at their desk. If they need more realism, a compact simulator adds physical vibrations through the seat and the steering wheel. For the absolute ultimate immersion, there are these huge full-motion simulators. And get this, there's even a version that lets you drive a real car on a real road, but you hear the virtual sounds of the new design through your headphones. It's wild.
So all of this sounds pretty futuristic, I know, but it's not science fiction. This digital-first approach is already being used by the world's biggest car brands. It's shaping the very vehicles that you see out on the road today.
All right, take a look at this number, 75%. In any kind of manufacturing, that is a huge figure. So what does it actually represent?
That's how much of the sound design and tuning for the new all-electric Ford Puma was finished in the simulator. 75%, all done before a single physical car was ever built. I mean, can you imagine how much time and money that saves? No more costly last-minute fixes.
Now, for a brand like Ferrari, the challenge is totally different. Their engine sound isn't something they want to get rid of. It is a core part of their billion-dollar identity. It's their music. So they use this virtual world to perfectly sculpt and fine-tune that legendary Ferrari roar, making sure it's absolutely perfect while still meeting all the super strict modern noise rules.
And it's not just the car companies themselves. A supplier, like BASF, uses these simulators to prove their new lightweight materials are ready for prime time. They can run virtual tests and show a carmaker that their new composite bracket will save a bunch of weight without compromising that premium solid feel of the car. It gives everyone the confidence to use the latest and greatest tech. So what this all comes down to is a fundamentally smarter way to engineer a car. It lets teams make those big, important decisions with confidence way early in the process. It slashes the number of physical prototypes they need, which saves a massive amount of time and money. But really, the most important thing is that it finally connects the hard science of engineering with that deeply human feeling you get when you're behind the wheel. Which all leads to one last, really fun question. Now that sound can be designed with this much precision, the possibilities are just endless. So if you had the tools, what would your perfect car sound like? Would you go for that futuristic hum of an electric spaceship, the classic deep roar of a muscle car, or maybe the ultimate luxury is just perfect, absolute silence? The secret language of our cars is being rewritten, and we're all along for the ride.